Before we begin on our next topic, let's review what we did from the last video on slope. For this graph, I want you to try and find slope just according to the visual. Pause the video and then unpause to check your answer. For this graph, we see that as x increases by 1, y decreases by 3, showing that the slope is -3. For this problem, I want you to use the equation with the points that were given. Once again, pause the video until you have attempted the problem. If we plug in the points, we see that the top equals 3 minus 1 over 2 minus 1, which gives us 2 over 1, or just 2. This means that the slope is 2. Let's try another. When you're looking at this graph, make sure to consider the scale of the x-axis. As you can see, the x values increase by 2 instead of 1. Take a minute to try this out and then unpause to check your answer. We can see from the graph that as x increases by 2, y increases by 3. So we can figure out that when x increases by 1, y should increase by 3 over 2. This makes sense because we know that x and y are proportional. So, as x increases or decreases by a constant, y should also increase or decrease by the same constant. Now, let's get back to intercepts. What are intercepts? There are two types, an X-intercept and a Y-intercept. An X-intercept is a point at which the graph crosses the x-axis. The Y-intercept is the point at which the graph crosses the y-axis. Let's look at the graphs from the last video. Based on the definition of intercepts, we know that all of these graphs have both an x and a y-intercept. Since we know that an x-intercept is the point at which the graph crosses the x-axis, we know that the y value of that point will always be 0. We can see this on the graph. And since the y-intercept is the point where the graph crosses the y-axis, we know that the x value of that point will always equal 0. We can also see this on the graph. Let's look at some examples. What are the x and y-intercepts of this graph? Well, we see that the graph crosses the x-axis when x equals 4. So the x-intercept has to be 4, 0. We also see that the graph crosses the y-axis when y equals 2. So the y-intercept has to be 0, 2. Try this one by yourself. What are the intercepts of this function? Well, the graph crosses the x-axis at x equals -3. So the x-intercept has to be -3, 0. We also see that the graph crosses the y-axis at y equals -5. So the y-intercept is 0, -5. Just as a bonus, let's figure out what the slope of this graph is. We know that as x increases by 3, y decreases by 5. So if we divide by 3, we see that as x increases by 1, y decreases by 5 over 3. So the slope is -5/3. It can also be interpreted as rise over run, the change in y over the change in x. Now, back to intercepts. What if we had an equation instead? How can we figure out the intercepts? Well, remember, we know that every x-intercept has a y value of 0, and every y-intercept has an x value of 0. So if we have an equation like this, all we have to do is plug in 0 and figure out what the other coordinate would be. Let's try it out. When we want to find out the x-intercept, we plug in y equals 0 because each x-intercept has a y value of 0. We solve and we figure out that x equals -5. So the x-intercept is -5, 0. We can do a similar thing to find out the y-intercept. Since we know that x equals 0, we plug in x equals 0 and solve to figure out what y is. We find out that y equals 10 when x equals 0. So the y-intercept is 0, 10. We see that the y-intercept is the number that's added to 2x, also known as b. This is an important concept to understand. When given a linear function, y equals mx plus b, we can easily figure out that the y-intercept is 0, b. When we plug in 0 for x, we will always get y equals b. What about this graph? What are the intercepts? Well, as we can see, the graph never crosses the x-axis because y always equals 6. So for this graph, there are no x-intercepts. But we can still figure out that the y-intercept equals 6 because when x equals 0, y equals 6. This means the y-intercept is 0, 6. The slope of this function is 0 because if we plug in 2 points, let's say 0, 6 and 5, 6, we get 0 over 5, or just 0. Let's do another example. What are the intercepts of this graph? Well, as we can see, this graph never crosses the y-axis because x always equals 5. So for this graph, there are no y-intercepts. But we can still figure out the x-intercept because when y equals 0, x equals 5. This means the x-intercept is 5, 0. The slope of this graph would be undefined because if we plugged in some points into the equation, such as 5, 0 and 5, 3, the equation comes out to be 3 over 0, which we know is impossible because the denominator of a fraction can never be 0. You can also think about it like this. There is a rise but no run, so it would be some rise over 0, which as we know is undefined. In this last graph, we see that the x and y intercepts are the same, because when x equals 0, y equals 0, and when y equals 0, x equals 0. So, the x and y intercepts are both 0, 0, because the graph passes through the origin. Let's review. We know the following things. X-intercepts are points at which the graph crosses the x-axis, while y-intercepts are points at which the graph crosses the y-axis. We can figure this out by looking at a graph or plugging in 0. For y-intercepts, x equals 0, and for x-intercepts, y equals 0. We also learned that horizontal lines do not have x-intercepts, while vertical lines don't have y-intercepts. The slope of a vertical line, such as this, is always undefined because the denominator of the slope is always 0. The slope of a horizontal line, such as this, is always 0 because the numerator of the slope is always 0. Slope is also considered rise over run, or how much y changes over how much x changes. Next week, we'll start to explore how these parts, slopes and intercepts, come together to create a linear equation. I hope you guys enjoyed this video. I'll see you next time.